Okay, so this is the homework booklet for the water topic. So the first question says, gives you loads of information about testing samples of water, and it asks you to describe an experiment to see which sample is the hardest, okay? You would be provided with soap solution and basic laboratory equipment, okay? So say how you'd make it a fair test and how you would know that the sample is the hardest, okay? 5 marks, quite a high marked question. So the first thing I do is measure out 20 centimetres cubed of each sample. So these are my water samples. I'd measure out 20 centimetres cubed. If you wanted to go really accurate, you would say, oh, I'm going to use a measuring cylinder, or I'm going to use a pipette. Okay, so if I wanted to go really fair test and explain what I was doing. Then I place 1 centimetre cubed of soap solution in sample A and shake for 5 seconds. Okay, again, a bit of a fair test. Continue adding 1 centimetre cubed of soap and shaking for 5 seconds. So every time you do it, you're shaking for 5 seconds until a lava forms. Okay, so then I'd record how many centimetres cubed of soap it took for me to form a lava. Okay, then I repeat with my samples B and C. The one that requires the most soap to form a lava is the hardest. The box below contains some statements about hard water. Choose one statement for each. Give a health benefit. Okay, so health benefit would be strengthens bones and teeth. Describe why hard water causes problems in boilers and water pipes, forms limescale when heated. Is an opinion but not a scientific fact. People believe it tastes better. So the next one then is looking at our separating mixtures. This here is distillation. Okay, straight away we should know that that's something that we've done, separating two liquids based on their boiling points. Choose the answers to part I and II from the box. Okay, nice question, again from the box. So first of it says label apparatus X. Okay, apparatus X is a condenser. It's got cold water flowing through. That's how we kind of know, because cold water has been heated there. So if we wanted to turn a gas to a liquid, we need to condense it. So it kind of starts to think about what's going on there. Give the name of method B. Method B is chromatography. Give the letter of the method you'd use to separate ethanol, which has got a boiling point of 78, from water with a boiling point of 100. Okay, I won't be able to use that because they're both, this one separates a solid from a liquid, so I won't be able to use that. Won't be able to use that because that separates inks or food colouring, so it's got to be C, which is distillation. So another kind of like table showing two different people having completed an experiment to work out which sample of water is a permanent lava, okay, or a permanent hard water. In each case, 25 centimetres of the samples are used and the soap solution was added 1 centimetre cubed at a time. So it's very similar to the first question that we did, okay. Two pupils, David and Haf, calculated the mean value for sample B. David calculated a value of 13.5, Haf calculated a value of 12. Show how both values were obtained and state which is the better value. Okay, so I showed how both values were obtained. So David took all of the values from sample B, took all of them, and there were 4 different samples and he divided by 4. Whereas Haf took out the anomaly because it's too big, it's not a number that fits, it's not in the trend, and then just divided by 3. Okay, Haf is a better value. She has removed the anomalous result and her results are more repeatable. So she's kept her values within a range of repeatable data. State which of the water samples A, B or C is the least hard. Okay, because it has quite a low value after boiling. State which of the water samples A, B or C contains both temporary and permanent hard. Okay, B, because the results get low after boiling, but not as low as C, which is definitely just temporary hard water, but still needs a lot of soap to finish to form a lava. Name the ion which causes hardness in water, calcium or magnesium. Again, question about which identify 2 ions which cause the hardness in water, magnesium and calcium. This is exactly the same question now. You are provided with some soap solution and 2 different samples of water. See, this question comes up quite a lot for 5 marks. Describe a simple experiment you could carry out to show which sample is harder. Include how you would make it as a fair test. So this time I thought about what was going to be my fair test first. So I wrote loads of different things down. Force of shaking, same type of soap solution, same volume of water, same volume of soap solution, added each time shaking. Okay, and then I gave quite a detailed method. Measure out 25 20 centimetres cubed of sample A. Measure 1 centimetre of the soap solution. Shake for 5 seconds. Remember, we've got to keep our shakes exactly the same. Continue adding 1 centimetre cubed and shaking until a lava forms. Repeat with another sample of water. More soap needed, the harder the water. Finally then, looking at DMT and fluoride. So the graph shows why a water company want to add fluoride to the water. Okay, and they've got data about the percentage of fluoride in the water and how many DMFTs, which means decayed, missing or filled teeth. State how the data in the graph can be used to persuade people that adding fluoride to drinking water is a good idea. Okay, more water is fluorinated, the less cause of DMFT there is. Discuss why some people are against the fluorination of water supplies. It's a form of mass medication against human rights, and it can also cause bone cancer and fluoridosis.